Hi, my name is Maruti and I'm the co-founder of Krakow. In this video, we'll discuss 8 most important LRDI sets for CAT. All the sets are taken from our DashCat mocks. So if you are planning to attempt our DashCat mocks, go ahead and attempt them before you watch this video so that you will be avoiding any spoilers. By the way, the t-shirt that I'm wearing is the t-shirt that we give for the toppers of DashCat. So in every DashCat, the top 5 students get one t-shirt. So if you want a t-shirt like this, give your best in our DashCats. Coming to the video, we'll first show you the group information, followed by another slide which contains all the 4 questions. So use these 2 slides, pause the video if you want, and try to solve the set on your own. If you're not able to get the solution, or if you want to check your answer correct, then watch the video solution that follows. Other than that, one more thing that we want to tell you is that we have 3 free CAT mocks on our website. All the mocks are in the latest pattern and they have detailed solutions. In addition to that, we have PDFs of previous papers of all the important MBA exams. We have all the previous papers for CAT, XAT and IFT. We are recently uploading even the previous papers of TISNET. So if you want any of these previous papers, you know where to find. You go to Krakow or search in Google for Krakow previous papers and you will be able to download the PDFs for all these previous papers. So let's get started with the video. In this question, it has been given that there are 6 students, their names are given and they have attempted 10 subjects. The numbers of the subjects are from S1 to S10 and they have scored different marks. Now it has also been given that the maximum and minimum scored by each of the students has been given. It has also been mentioned that in any 2 consecutive subjects, a student may either score 2 more than the earlier one or 2 less than the earlier one, or the score might remain the same. What they are basically saying is that if you are plotting a graph of the subjects, say this is S1 score, S2 ... S10, and this is marks. What they are saying is that it will be a smooth graph. It will be a smooth graph. It won't be a haphazard graph. It won't be like this where the changes between consecutive subjects is a lot. So it will be basically a smooth graph where between S1 and S2 this difference will not be greater than 2. It can be 0 like this where it is flat between S2 and S3, but it won't either increase massively or decrease massively amongst consecutive subjects. This is the information that has been given. We know the minimum and maximum given. So let us start attempting the questions. In the first question, it is given that if all the students score 26 in subject N, what is the maximum possible value of N? So if you look at the maximum and minimum given by each of the students, we will notice that the difference between the maximum and minimum in each of these cases, if we plot, this is 14, this is 14, this is 10, this is 10, this is again 14, and this is 10. So in any sort of having some sort of a constraint, it is always better to first look at the ones where the difference between the maximum and minimum is a lot. So if you are first looking at, say, Arya, she has scored a minimum of 20 and a maximum of 34. And we want to make her score of 26 as close to the 10th subject as possible. There is another thing that you should observe, that to go from 20 to 34, that is from the minimum to maximum, the difference is 14. And because the consecutive subjects can change by a maximum of 2, this is definitely going to take 14 by 2, that is 7 steps. And including the first step, there will be a total of 7 plus 1, which is equal to 8. Now, if you want to fit 26 amongst this, we will have to try to plot a graph for her. So this is S is equal to, this is marks equal to 26. Now, we first notice that 26 is closer to her minimum, which is 20, than to her maximum, which is 34. So if her plot is decreasing, it will intersect this line much further ahead. So we have to ensure that she starts off with 34, then goes down, goes flat for some time, goes somewhere, and finally she'll intersect this at 26. This is her subject. This is, say, S of N, and her score in S of 10 has to be 20. Again, it has to be 20 because we notice that 26 is closer to 20 than 34. So this 26 has to be closer to the end, so it has to be this way. Now if you want to maximize N, we have to ensure that there is no line which is flat from S of N to S of 10. That is For every consecutive subject, there is always a drop. There is nothing which is flat. So if she has scored 20 in S of 10, she will score 22 in S of 9, she will score 24 in S of 8, and she will score 26 in S of 7. So we can conclude that for Arya, n can't be equal to 8 or 9 or 10. N is definitely less than or equal to 7. This is what we can conclude. So now we will try to see if by putting n is equal to 7, we can make all these students get 26 in the 7th subject, having the minimum and maximum that is given. Now if you are looking at the next one, which is Arti, she scored a minimum of 18 and a maximum of 32. Here 26 is closer to the maximum, so her graph will be upward trending. Now if you are looking at it this way, she starts off with somewhere around 18, flat, goes up somewhere, and finally she will intersect this S of 26 and S of n, and the maximum is reached when S of 10 is equal to 32. Now this is S of 10, S of 9 can be 30, S of 8 can be 28, and S of 7 can be 26. And also notice that from 18 to 26 you can easily reach in 7 steps. So for for Arti, a case exists where S of 7 is equal to 26. For Arya also a case exists where S of 7 is equal to 26. What we are trying to prove is, we will draw a graph for each one of them where S of 7 is equal to 26. If that can't be found for any of them, then we will try to do it for S of 6. And if that also is not possible, we will go for S of 5, and that is our strategy. Anyway, we have proved S of 7 for Arya and Arti. We will go now for Asu. Her minimum is 22 and her maximum is 32. 26 is closer to the minimum than the maximum. So let us, her graph will be a downward trending graph. So if you are looking at it this way, where this is S of marks equal to 26, she will start off with 32, come down flat, come down somewhere flat, and finally she will intersect this at 26, and she will end at 22. This is S of 10. Now S of 9 can be 24, and in her case we can actually make S of 8 to be 26, but we don't need S of 8 because we know that n is less than or equal to 7. So we can easily find a case where S of 7 is equal to 26. We can just say that S of 7 is equal to 26 and S of 8 is also equal to 26. So she basically got it flat here and then she came down. So for her also S of 7, we can find a case where S of 7 is equal to 26. Now for Ananya, her minimum is 24 and her maximum is 34. Clearly 24 is closer to 26, so it will be a downward trending graph. If you draw from 34 flat somewhere, this is S of 26. Finally she will intersect it here and then she will come down. S of 10 is equal to 26. In her case, S of 9 itself can be 24. So S of 7 can easily be 24, where you can say that S of 8 and S of 7 are also flat. So S of 7 is equal to 24, S of 8 is equal to 24, S of 9 is 24, and then S of 10 is equal to 26, where it falls. So again, this is quite possible. For Ananya also, S of 7 is equal to 26. For Anya. Now if you are looking at Ananya, her minimum is 60 and her maximum is 30. So 26 is close to her maximum, so we have to draw a upward trending graph. Now if you are drawing an upward trending graph starting from 16, you can finally reach this as S of 30 is equal to S of 10, 28 will be S of 9, so 26 can easily be S of 8. So this can definitely be S of 7, where it is flat over here, and then it comes down from S of 7 is equal to 26. We have to ensure that S of 1 is equal to 16. This is quite easily possible because the difference is only 10 and we have 6 steps. So even in the case of Ananya, S of 7 is equal to 26 is possible. In case of Aditi, the minimum is 20 and the maximum is 30. So 26 will be closer to the maximum, so it will be an upward trending graph. Again, if you draw it from 20, some graph where S of 10 is finally 30, S of 9 is 28, and S of 8 is 26. So again, we can easily find a case where S of 7 is equal to 26, where it is flat at 26, and from S of 7 to reach 20 in 6 steps is quite easily possible. So even in this case, S of 7 is equal to 26 is possible. So what we have actually proved in this is that in the case of Arya, S of 8 or S of 9 or S of 10 that is her scores in these 3 subjects, cannot be equal to 26. We have proved that for all of them S of 7, there exists a case where S of 7 is equal to 26. Now using these two, we can say that the maximum possible value of n is equal to 7. So now let us look at the next question. In this question, we are given that the maximum average score possible for a student A be x and the minimum average score possible for a student be equal to y. Then for how many students the value of x minus y is an integer. So we have to find out the maximum possible average of each of the student. We also have to find out the minimum possible value of the average for each of the students, subtract them to get the respective difference in averages, and we have to see for how many students that x minus y is an integer. So what we will do is, instead of calculating the average, we will calculate the maximum possible value of sum, that is sum of the scores, maximum possible value of sum. We will call it P. We will also call the minimum possible value of sum because it makes calculations easier, and we will call it Q. Now we will find for how many of these cases P minus Q is a multiple of 10. This is what we will try to do. In the case of Arya, in order to maximize the sum, we will have to ensure that she reaches her peak, that is 34, fast, and then any of the extra steps that is needed, she will spend at the maximum. For example, for her to maximize, she will start with 20, she will reach 34 in a straight line, and she is going to take from 20 to 34. If this is S of n, 34 will be S of 8, and the remaining 2, that is S of 9 and S of 10, she is going to spend here, 34 and 34. This is where her sum is maximized, the total score that she has obtained. Similarly, for her to minimize, what we will do is, we will have to draw a graph where she starts from the top, she starts from 34, she will come down to 20 fast and then spends the remaining here at 20. So the last 2 will be spent here. So over here, for every one of them, we will have to see the difference between the maximum and the minimum. In case of Arya, the difference is 34 minus 20, which is equal to 7. And so the first 8 steps, including the first, that is 7 plus 1, are spent from coming to the maximum to the minimum, and this is the same in both the cases, whether it is the maximum or the minimum. But in order to find the maximum, we will give the remaining 2 subjects the maximum score, that is 34, and in order to find the minimum, we will give the remaining 2 subjects the minimum score, that is 20. This will help us in calculating the answer faster. So if you are looking at the maximum value for Arya, P is equal to 20 plus 22 plus dot 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 plus 34. This is common between the 2, and the last 2 will be 34 into 2, where the remaining 2 she spends at the top, and the minimum will be 20 plus 22 plus dot 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 plus 34 plus 20 into 2. Notice that these are 8 numbers, that is how we are getting the 2 here. So if you are subtracting P minus Q, the answer will be 14 into 2, which is 28. This is not a multiple of 10. Therefore, in this case, x minus y will not be an integer. So in the case of Arya, not an integer. Now let us look at the case of Aarti. She starts with 18, that is her minimum, and her maximum is 32. So she takes 32 minus 18 is 7 steps, plus 1 is 8 steps in going from the minimum to the maximum. So she has a reserve of 2 steps. So in her case, P will be 18 plus dot 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 plus 20 plus dot 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 plus 32 into 2. Similarly, Q will be 18 plus 20 plus dot 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 plus 32 plus 18 into 2. Therefore, P minus Q will be again 14 into 2, which is 28. Therefore, which is not a multiple of 10. Therefore, x minus y is not an integer. So even in the case of Aarti, x minus y is not an integer. If you look at Asu, in the case of Asu, her minimum score is 22 and the maximum score is 32. So the difference between these two is 10 units. So it is going to take her 10 by 2 plus 1, that is 6 steps. So the remaining is 4 steps. So P minus Q will be, we can automatically put it as 32 into 4 minus 22 into 4, which is equal to 40. So, and this is a multiple of 10. Therefore, in this case, x minus y will be equal to 4, which is an integer. So, in the case of Asu, it is correct. Now, if you are looking at Ananya, her minimum is 24 and her maximum is 34. Again, to go from the minimum to maximum, it is going to take her 6 steps. Therefore, there are 4 steps which are in reserve. In order to maximize the sum, all 4 steps should be 34, and in order to minimize the sum, all 4 steps should be 24. Therefore, P minus Q, where P is the total sum and Q is the minimum sum and P is the maximum sum, is equal to 34 into 4 minus 24 into 4. This again is equal to 40. Therefore, x minus y is equal to 4, that is 40 by 10. So, this is also possible, where this is also an integer. Now, if you are looking at the next one, which is Ananya, she scores a minimum of 16 and a maximum of 30. So, the difference is 14. So, the number of steps that it takes to reach from the minimum to maximum is 8 steps. Therefore, there are 2 steps which are in reserve. So, in this case, the difference between the maximum possible value and the minimum possible value of the sum is 30 into 2 minus 16 into 2. This comes to 28. This is not a multiple of 10. Therefore, x will equal 2.8, which is not an integer. So, in case of Ananya, it is not true. If we are looking at the final case, which is Aditi, she scores a minimum of 20 and a maximum of 30. Difference is 10, which is covered in 6 steps. Therefore, 4 steps are in reserve. In this case, again the value of P minus Q will be 30 into 4 minus 20 into 4, which is equal to 40, which is a multiple of 10. Therefore, x will equal 4, which is an integer. So, in case of Aditi also, x minus y is an integer. So, the number of possible values of students where x minus y is an integer is 3. This is the answer. Now, let us go to the next question. How many students cannot have an average score equal to 26? This is similar to what we have done in the earlier question, where we were trying to find out the maximum possible score and the minimum possible value of their score. Here we will calculate the total sum instead of the average. So, we have to find out for how many students the total sum will not equal 260. Now, for that, let us first again start with Arya. She has 20. If we are looking at her sum, there will definitely be 8 subjects where the sum is 20, 22, ... 32 and 34. These 8 scores will always exist for her. Now, she has only a reserve of 2. Now, if you are looking at 20 plus 22 plus ... plus 34, we can easily calculate this as equal to 27 into 8. 27 is the average of 20 and 34, which is 54, by 2 is 27, and the number of such numbers is 8. So, 27 into 8 is equal to 216. Now, there are 2 steps which are in reserve, and the 2 steps should equal 54, that is 260 minus 216 is equal to 54. This is quite easily possible by saying the 2 numbers are 26 and 28. So, if you want to draw the graph, we are saying that she starts with 20, goes on till 26 in a straight line, then waits here once, then goes to 28, waits here again, and then goes on till 34. In this kind of a graph where there is one extra 26 and one extra 28, the sum will equal 260. Therefore, her average will equal 26. So, in the case of Arya, average of 26 is possible. Now, if you are looking at Aarti, she starts from 18 and she goes till 32. Again, there are 8 steps which are covered in this, and the total will be 25 into 8, which is 200. The total we need is 260, and the number of steps that she has in reserve are 2. So, she can again easily make 60 up in 2 by saying that the remaining 2 are 30 and 30 each. If you draw the graph, she starts with 18, goes in a straight line till 30, stays here for 2 extra steps, and then finally goes till 32. The sum of all the marks that she scores in this graph will equal 260. Therefore, even in her case, she can have an average of 26. Now let us look at Asu. Asu starts with 22 and she reaches 32. Here she is taking 6 steps and the sum will equal 22 is 27 into 6, which is equal to 162. The total we need is 260. So the difference between 260 and 162 is 98. And how many steps does she have in reserve? She has 4 steps. She has 4 steps in reserves because to go from 22 to 32, it only takes her 6 steps. Now we have to find out 4 steps such that the sum equals 98. Again is quite straightforward. It is 24, 24, 24 and the final one will be 26. Notice that 24 into 4 is 96. So if we keep 3 as 24 and the fourth one as 26, we will get this sum. So again, for you to visualize, we can easily draw a graph where she starts from 22, goes to 24 and waits at 24 for 3 more times, then goes to 26, waits here once and then continues to go till 32. In this case, the total sum that she scores in all the subjects together will be 260. So even in the case of Asu, she can get an average of 26. Now if you are looking at Ananya, she starts with 24 and she goes on till 34. So there are again 6 steps involved. And the sum is 34 plus 24 is 58 by 2 is 29. So the sum will be 29 into 6, which is equal to 174. And the total we need is 260. So in the remaining 4 steps, she has to make 86. 260 minus 174 is 86. But clearly this is not possible. Why is this not possible? Because 86 by 4 is less than 24. So the sum of these 4 steps is less than 86, but the minimum score that she received is 24. So there is no way in which you can add 4 more steps without the total exceeding 26. So in this case, Ananya cannot have a distribution of her scores in the subjects where the average is 26. Similarly, if I am looking at the next one, which is Ananya, which is she starts from 16, 18 plus dot 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 plus till 30. The difference is 14, so this takes 8 steps and she makes 23 into 8, which is equal to 184. The total that we need is 260. So amongst the 2 reserve steps, the sum of those 2 steps should equal 76. This also is not possible because the average needed in this 2 will be 38, but the maximum that she scored is 30. So we can't have 2 steps totaling, that is the marks in 2 subjects totaling 76 when the maximum that she scored is 30. So even in case of Ananya, the average score of 26 is not possible. If I are looking at the final case of Aditi, she starts with 20 and she goes till 30. This takes 6 steps and the total is 150. This is 25 into 6. What we need is 260. So in the remaining 4 steps, she has to make up 110. This is again possible because 108 is 27 into 4. So you would need 26, 28, 28, 28. That is 328 is 84 and 126 is 20. The total will become 110. Again, you can easily draw this graph where she starts with 20. She goes till 26 in a straight line, waits there once, then goes to 28, waits there for 3 more subjects and then finally reaches 30 in the last subject. In this kind of a distribution, she is going to make a total of 260 so that her average will equal 26. So Aditi can do it. So if you are answering the question of how many students cannot have an average score of 26, it is 2. They are Anya and Ananya. Now let us go to the last question. In this question, we have to find out in subject 6 the maximum and the minimum score of Ananya, and then we have to find out their sum. If you are first finding the maximum, we will make it an upward trending graph where her minimum is 16 and her maximum is 30. So in 6 subjects, that is in this 6 subjects, we want her to score as much as possible. So from 16 she will go until 26, and here maybe like flatten out a little and finally reach 30. This is the case in which the score S6 is maximized for Ananya, in which case this is 26. If we are looking to minimize her score, we have to again make a downward trending graph where she starts from 30, comes down as much as possible in the first 6 subjects. She will come to 20 where she starts from 30, and here flatten out a bit or come down and then flatten, finally ending at S of 10 is equal to 16. Notice that it is not needed that S of 10 is equal to 16, but what is more important is that this has to be straight line. There can't be any flattening out in the first 6 subjects if you are trying to minimize S of 6. So in this case the total will be 26 plus 20. This is the maximum score of S of 6 and 20 is the minimum score of S of 6. So the total will be 46, which is the answer.
The secret to crack CAT is taking a lot of marks. We at Krakow give all the previous year's CAT, XAT and IFT papers in the actual exam format. Also, if you just Google Krakow free CAT mark, you can find 3 free CAT marks in the latest exam pattern. You can take them and get detailed analysis.
In this data interpretation set, it has been given that there are 5 races A, B, C, D and E. They participated in a competition, and each of the 5 races are race 1 to race 5, and the prizes are given for the first 3 races in each of the races. The amount of prize money that is given varies from race to race, and it is given in the table given. Now we are also given some additional information. The information that has been given is that all the racers secured a different position in each race. That is, in one of these races A came first, in another, but he didn't come first in any other race. Similarly, he came second in one of the races, but he didn't come second in any other race. So this is basically like a Sudoku where each of them comes first only once and each of them comes second only once. So if you actually draw a table with the same table that has been given but without the prize money, say this is race 1, this is race 2, 3, 4 and 5, and this is the name of the person who came first, and this is the name of the person who came second, this is the name of the person who came third, and this is the name of the person who came fourth and fifth. Clearly in the information we haven't been given any data about the persons who came fourth and fifth, so let's ignore that first now, but we'll have to fill up this table with the names A to E, and the first line actually suggests that each of the racers have come in different positions in each race. So that would mean that if somebody has come, if a name has been inputted here, something like say A, none of the columns that are given below have A, because A comes first only once, and because A has come first in this race, he wouldn't occur anywhere in this race. So there will be no sort of duplication either in a row or in a column. This is a important thing to remember. Secondly, it has been given that the total money that has been won by A is 2100. So we can find out different combinations. For example, 900 plus 1000 plus 200, or 800 plus 1000 plus 300, or there are many combinations, 1500 plus 400 plus 200. This obviously won't work because both of them are in the same row, but you get the sense. Similarly, it has also been given that E has won a total of $500 and C has won a total of $800. It is also given that B, the most money was won by B. So he would have won greater than 2100, which is won by A. Now if you look at these things, we need to fill up the table so that we can solve the questions which are given in the DI set. Now one of the key things that we should remember is, I would suggest, is going by the exact number that is given, that is either by 2100 or by 500, because we know exactly the amount of money that has been won. So if you can find different sets over here which total up to either 2100 or 500, we will be able to fill up some dots. If we instead go with total money won, this is vague, that the total money won by B, we don't know the exact number that has been won by him. Similarly, going by the amount of money that has been won by C, which is less than 800, is also vague. We don't know whether it is 500 or 600 or 650 or anything. So if you are looking to fill the data with either A or E, we would notice that if we are going with the information that E has won $500, there is only one combination which will allow that. That is, he comes first in race 5, he comes second in race 4, and he comes third in race 2. These are the only three numbers which actually add up to 500. If you look at any other number, any other combination, it won't match up to exactly 500. So this is the first clue that we use to fill up some parts of the table. So he has come first in race 5, he has come second in race 4, and he has come third in race 2. So these three are E. Second, we will use over here the fact that E has won less than C has won less than $800, because then we can easily fill up that C has won race 4. Because if C wins any of the other three, he would be getting more than $800. So we know that this is won by C. So the B, A and D have come first in race 1, 2, 3, just to make it clear. Now if you look at the other one, which is that A has won $2,100, there are different combinations for that. One of the combinations is, if he has won say 1500, that is if he has won race 3, he needs $600 from the other two races, and the only possible way is 400 plus 200. But in this case he can't come both second and third in race 2. So this case is something that we can reject. Similarly, if you are looking at the first case, if he has won say $900 from the first race, he needs 2100 minus 900, that is 1200 from the other two races. There are combinations which will give him 1200. One of the combination is 1000 plus 200. I think that is the only combination possible. So one of the combination is 900 plus 1000 plus 200. But we reject this case also because E has won 200 in race 3. We know that, and we have filled it up that E has come third. So this case is also something that we can reject. Now the final case is A has won the second race, that is he has won $800 from second race, and he needs 1300 more. So the only way possible is this 1000 plus 300. So 800 plus 1000 plus 300 is a valid combination, and this is the only valid combination which is surviving. If you look at it, A has won the second race, and he has gotten 1000 from the third race. So he has come second in the third race, and he has won 300 from the third race. So he has won 300 from the first race. So this is the table that we are filling up. So we have gotten this information possible from the table that has been given. Now we'll try to see, we'll use the fact that the total money won by B is the highest. For B to win more money than A, which is greater than 2100, he has to win 1500 from race 3. Because there are only two options remaining, which is 900 and 1500. If he wins $900 in the first race, the second race, the 1000 has already been won by A. So for him to win more than 1200 from the other two races is not possible using any of the combinations given. So it is imperative that B wins race 3. So we know that B has won race 3. Now because this is the case and this is like a Sudoku, the race 1 has been won by D. These are things that we can actually fill up. Now once this is done, we'll try to go forward for the next ones. Now from this table we know all the values for only A and E. We'll try to fill up the values for B, C and D. One of the things that when I say we are filling up the data is we are not looking for people who have won 4th and 5th, because there is no information that has been given from the table. We are just trying to fill out the first 3 columns in the given table. Now if you look at the next one, if you look at for example who has come second in race 1, that is this one. Now if you imagine that this is a Sudoku, we know that this can't be either A, because A has come second in race 3. This can't be E, because E has come second in race 4. And this can't be D, because D is present already in the row by coming first in race 1. So this has to be either B or C. Now the prize money for this is 600, and we already know that C has won 300 from race 4 by coming first. So this can't be C, because if C has won this, he would have gotten $600 here, that is this 600 and $300. So total he would have won is greater than 900. But we know that he has won only 800. So we can actually fill up that this is B. So we know that B has come second in race 1. Now we are again using the same strategy, because we know that C has won $300 here. He can't win 500 in race 3, because then the total will become 800, and whatever money he wins by coming second in any of the races is greater than 0. So the total money won by C will be greater than 800, and we don't want that. So we can know that C did not come third in race 3, and the reason we are actually doing that is again trying to fill this up like a Sudoku. If you look at this box, we know that it is not A, because it is there in the same column. We know that it is not B, because it is there in the same row. We know it is not E, because again it is there in the same column, and we have just proved that it is not C, because if C has won $500 here, his total will be greater than 800. So this has to be D. Now once we have realized that this is D, we know that this is not C, the row below it, because C came first in race 4. Now so we have to make this B, because we can rule out A, E and D, because they have come third in other races, and we know it is not C. Similarly, the row below that is coming third in race 5 has to be C, because no other alphabet exists. Similarly, if you are trying to fill up C in the second column, C has to be in the second row. C has to be in the second row, because C can't end up in the 5th row, because the third column already has C. Similarly, if you are trying to fill up the last remaining square, it has to be D, because all other terms exist here. So if we just fill this table up in a slightly neat manner, so that we can use it, I'll just clear this so that we can fill the table up in a more neat manner, so that we can answer all the questions which are given in the group. I'm only concerning myself with the 3 columns, because I don't want to talk about who has come 4th and 5th. This is race and this is the positions. So it is D, A, B, C and E. B, A, C, A, E, D, A, E, D, B, C. I just filled up the information from the above table, so that we can now go and quickly answer the questions in the group. How much money does B win in the competition? Now if you look at it, B has won 1500 and 600 and 100. These are the 3 positions in which B has come. So the total will be 2100 plus 100 is 2200. So the correct answer is B. We go to the next one. Who secured 3rd position in race 3? This is the race, this is race 3, it is D. So the correct answer will be D. Who secured 4th position in race 2? This is race 2, this has to be the 4th position. Here we don't know who has secured the 4th position. We do know that it is either B or D, because the first 3 positions have been secured by ACE, but we can't say for sure that it is either B or D. So it can be either B or D. So the answer is cannot be determined. The 4th question says that which of the following statement is correct? D secured 2nd position in race 1. This is race 1 and B has secured 2nd position. So this is wrong. The second one says C secured 2nd position in race 4. This is race 4 and E has secured 2nd position in race 4. So this is also wrong. The third one says D won $50 in race 5. This is race 5 and D has come 2nd. The prize money for 2nd position is $50. So this is correct. If you look at the 4th one, E won $100 in race 4. This is race 4 and he has come 2nd. And the prize money for coming 2nd is $200. So he has won $200 and not 100. So the only statement which is correct amongst these 4 is option C. So to solve this, we have to first identify that this is some sort of a Sudoku, and we have to fill up all the details, and we should fill it up in the easiest way possible. Now we often advise students to solve Sudokus because it will help them in their LRDI, and this set is a live example of the same. If you are quick in solving Sudokus, you would have solved this set within like 5 to 6 minutes and you would have gotten all 4 of them correct. In this question, it is given that there are a total of 500 students in a school, and each student likes at least 2 subjects of physics, chemistry, biology and English. So whenever you see that there are different students who like different sets which can overlap. For example, over here it is given that a student can like either physics and chemistry, he can also like biology. So whenever you see that there are different sets where there is an overlap, this kind of a question is a Venn diagrams question. So in the normal Venn diagrams, if there are only 2 sets, so if instead of say physics, instead of 4 subjects here, if there are only 2 subjects, physics and chemistry, the Venn diagram would have been something like this. Once there are 3 sets, you will add one more circle over here, and once there is a 4th circle, you can add one more circle, but it gets fairly complex when there is 4. The different intersections cannot be seen quite easily. So there is a method in which we solve Venn diagrams of 4 and more elements. That is, we draw another Venn diagram where the different regions can be marked easily. So in this case, we would assume that this is basically the Venn diagram. Now this is physics, this is chemistry, this is biology and this is English. So there are, instead of having circles representing sets, we have a cylinder kind of a structure which will represent. So all the overlapping regions will indicate the respective set. For example, the one in bold over here is what physics is consisting of, and this one, for example, this area is occupied by only people who like just physics, and this is occupied by people who like only chemistry, and this is occupied by people who like only biology, and this is occupied by people who like only English. While if you look at this is occupied by people who like both biology and English. Similarly, this region is people who like physics, which is overlapping with people who like biology. So this is for people who like physics and biology. Similarly, this region has the intersection of physics, chemistry and biology. So this will be PCB. Similarly, this region is the overlap of chemistry and biology. It doesn't have physics, it doesn't have English, which is over here. So this is only chemistry and biology. Similarly, this region has chemistry, it has biology and it has English. So this is CBE. This region has chemistry, but it doesn't have either physics or biology and it has English. So this is chemistry and English. Similarly, this region has physics, it has biology, it has English, but it doesn't have chemistry. So this is PBE. Similarly, this region has physics, but it doesn't have biology or it doesn't have chemistry. So this is physics and English. This has all 4. This is the overlap of all the 4 sets. And this has physics, this has chemistry, this has English. So this is PCE. Once you can get this kind of a structure in place, the Venn diagram, answering this question becomes a lot more easier. So now we will draw a similar Venn diagram and try to solve the question that is given. So this is physics, this is chemistry. If you just look at these two, you can easily identify this is physics, this is chemistry, and the overlap, this region is where physics and chemistry intersect. This is all the people who like both physics and chemistry. Then we have, this is biology and this is English. Now the sum of all of these students is 500. So this is one clue we will remember till the end. We will try to put in different variables, but the total sum is 500 is what we will use to get one of the equations. Similarly, it is also given that each student likes at least 2 subjects out of physics, chemistry, biology and English. So the cells P, C, B and E, which represent only the students liking one of the subjects, are 0. So this will be 0, this will be 0, this will be 0 and this will be 0. Now the ratio of the number of students who like exactly 4 subjects to the number of students who like exactly 3 subjects is 1:5. Now this is the cell which represents the students who like all 4 subjects. Let us assume that it is X. Therefore the sum of these 4 cells, that is these 4 cells which represent the number of students who like exactly 3 subjects, is equal to 5x. That is another equation we will remember. we'll keep track of all the information that we are not actually representing in these sets to help us solve towards the end. This 5x is sum of 3. The number of students who like only physics and biology is 65. Physics and biology is this PB, this is 65. While no student likes only chemistry and English. This is chemistry and English, so this is 0. The number of students who like physics and exactly one more subject is 135. The number of students who like physics and exactly one more subject, this is PC, will be PB, PC and PE. The sum of these three is 135. We know that PB is already given as 65. So the sum of PC plus PE will equal 135 minus 65, which is equal to 70. So if we assume that PC is equal to A, PE will be 70 minus A. The number of people who like biology but not English is 185. The number of people who like biology but not English will be the sum of these 4 cells. That is PB plus PCB plus CB plus B. This is equal to 185. We know that this is equal to 65. So the sum of PCB and CB, that is these 2 cells, will be 120. So let us assume that this is B. So this will be 120 minus B. The number of students who like biology, chemistry and English but not physics, that is CBE, is same as the number of students who like physics, chemistry and English but not biology, that will be PCE. So these 2 cells are the same. Let us assume that they are D. This is D and this is D. The sum of the number of students who like only physics and chemistry, that is A here, that is PC, and the number of students who like only biology and English, that is BE, is this one, is 60. So this will be 60 minus A. The number of students who like biology, physics and English but not chemistry, that is PBE, is equal to 70. PBE is here, so this is 70. The number of students who like at least 3 subjects is 240. The number of students who like at least 3 subjects means the number of students who like 3 subjects exactly plus the number of students who like 4 subjects exactly is equal to 240. But we know that the number of students who like 3 subjects is equal to 5x and the number of students who like 4 subjects is equal to x. So x plus 5x is equal to 240, or 6x is equal to 240, or x is equal to 40 and 5x is equal to 200. So we'll replace x with 40 here and we'll remember that the sum of these 4 is equal to 200. These 4 cells represent the students who like exactly 3 subjects, and that sum will equal 70 plus B plus 2D is equal to 200, or B plus 2D is equal to 130. This is the first equation. It is also given that the number of students who like both biology and English is 195. So the sum of the intersection of biology and English sets will be 195. So the 4 regions which are part of that is this one, PBE plus PCBE plus CBE plus BE, that is 70 plus 40 plus D plus 60 minus A will equal 195. If you put it down, it is 70 plus 40 plus D plus 60 minus A is equal to 195. So you can simplify this as 170 plus D minus A is equal to 195, or D minus A is equal to 25. This is the second equation. Now remember that there is another equation that we can take care of, which is that the sum of all of these elements is equal to 500. That is the total number of students. So if you count the total number of students in each of them, it is 60 plus 70 is 135 plus 70 minus A is 205 minus A plus A plus B plus 40 plus D. So that is 40 plus A plus D, B plus D, plus This is 120 minus B plus D. So it is 120 minus B plus D plus 60 minus A. So this is all the term, plus 60 minus A is equal to 500. To simplify the LHS, let us first calculate the sum of all the constant terms. So 205 plus 40 is 245, plus 120 is 365, plus 60 is 425. If you look at the A terms, this is minus A plus A will cancel each other, and there is one more minus A, minus A. If you look at the B terms, this is B and minus B which will cancel each other, and if you look at the D terms, this is D plus D, so plus 2D is equal to 500, or 2D minus A is equal to 75. Now you can look at the third equation and the second equation, this one and this one, to calculate the value of D and A. 2D minus A is 75 and D minus A is 25. So D is equal to 50 and A is equal to 25. Similarly, you can use the value of D, which is equal to 50, to calculate that B will equal 30. So you have found out the values of each one of them. So let us try to draw the diagram here so that we know what exactly each of the sets contain, that is each of the regions contain. D is equal to 50, A is equal to 25 and B is equal to 30. This is what we have calculated. Now let us draw the sets again. This is the set containing physics. This is the set containing chemistry. This is the set containing biology, and this is the set containing English. Now as usual, there are no elements in the sets containing only one region, that is all 0. Now this is 65 and this is 70, these are constant terms. This is 70 minus A is 25, so this will be 45. This is A, so this is 25. This is B, so this is 30. The common intersection of all the elements is 40, and this is D, so D is 50. This is 120 minus B, B is 30, so this is 90. This is D, so this is 50. This is 0, and this is 60 minus A, 60 minus A is 45. Sorry, 60 minus A is 35. So this is basically the how different regions look. Now let us go to answering the questions. What is the total number of students who like English? So the total number of students who like English will equal the sum of all the elements in this region. So that will be 70 plus 40 plus 50 plus 35 plus 40 plus 50. This will be 70 plus 40 110 plus 50 is 160 plus 35 is 195 plus 90 is 285. Sorry, this is 45. So the answer will be 70 plus 40 is 110 plus 50 is 160. So this is 160 plus 35 plus 45 is 80 plus 50 is 130. So this will be 290. So the correct answer is 290. What is the ratio of the number of students who like biology to the number of students who like chemistry? So let us calculate the number of students who like biology first. It will be in this region. So that will be 65 plus 70 plus 30 plus 40 plus 90 plus 50 plus 35. So this is 85. This is 135. This is 70 plus 90 is 160. So 135 plus 85 is 220 plus 160 is 380. So biology is 380. Now let us look at chemistry. Chemistry is this region. This will equal 25 plus 30 plus 40 plus 50 plus 90 plus 50. This is 55, 90 and 140. So 230 and 55 is 285. So chemistry is 285. So the required ratio is 380 is to 285. 380 is equal to 95 into 4, and 285 is equal to 95 into 3. So the required ratio will be 4:3. Let us look at the next question. What is the sum of the number of students who like only chemistry and biology? The number of students who like only chemistry and biology is 90. And the number of students who like only English and physics. The number of students who like only English and physics is 45. So the required sum is 135. Now let us look at the final question. What is the difference of the number of students who like biology and the number of students who like English? We have calculated that the number of students who like biology earlier is 380. So that is 380 minus number of students who like English. This also we calculated earlier. This is equal to 290. English is 290. So the required difference will be 380 minus 290, which is equal to 90. So the answer in this case is 90. In this question, we are given two graphs. One depicts the salaries of the individual, and the next one depicts the team salaries. To understand this better, there is an office, and the office has different departments. There are 3 departments in the office. The names of the 3 departments are given in the second graph. It is finance, technology, and marketing. Each of these departments have different number of employees over the course of 4 years. That is 2016 to 2017, 2018, and 2019. Over these 4 years, the number of employees in each of the department is a distinct multiple of 10, but it is less than 130. So basically there are 3 departments and 4 years, so there are total of 12 numbers, and it has been given that they are all distinct multiples of 10 less than 130. So all of them are from 10, 20, 30 ... till 120. This is the first information that has been given. The second information that has been given is the salaries of the individuals. For example, in the first graph represents the salaries of the individual in different departments over the years. For example, in department Z in 2016, each employee got 10 units. Similarly, in department X in 2016, each employee got 6 units. Similarly, if you are looking at the team salary graph, here the exact numbers are given. So for example, in 2016, we know that total amount of salaries that has been received by the marketing team is 1100 units. Similarly, the total units, total salary that has been received by the technology team in 2016 is around 300 units. So this is the information that has been given, and we can look at the questions, but let us first put down the information that we already have in the form of 2 tables. One table will depict the salaries of the individuals, that is the data in this graph. The second one will depict the total salaries, that is the team salaries, in the second table. If you are looking at it, this is 2016, 2017, this is X, department X, this is department Y, and this is department Z. 2017, 2018. Our strategy is quite simple. We'll jot down both the tables, and we'll first try to identify what is X, what is Y, and what is Z. We can do that by trying to see the individual salaries and the total salaries, and there should be a multiple of 10. So if you are jotting down the information of X, in 2016, initially it is around 6. In 2017, that is, this is say around 7. In 2018, that is, this is say around 8.2. In 2019, over here, I think it is in the middle, so this will be around say 9. Now if you are looking at Y, it will initially start here, so I think it is close to say 4.2. Then Y is here, so that is say around 3.8. 2017. 2018, it is over here, so this is say 6. In 2019, it is 2. Now if you are looking at Z, this one, it is 10 at the start. Then over here is say around 6.5. No, sorry, not 6.5. It will be say around 7.5. then in 2018 it will be around 6.5, and in 2019 over here it is say around say 2.5. It is greater than 2 but less than say 3, so around this. This is the information that we have from the first graph. Now let us try to draw the second table and then try to identify what is x, what is y, and what is z. If we are looking at the second graph over here, again we will put down all the four: 2016, 2017, 2018 and 2019. Now this table represents the total salaries that have been received by the three departments. Now first is finance, next is tech, the third is marketing. So finance in 2016 over here is say around 250. These are just approximate numbers, don't worry, we will get the exact numbers later on. Now in 2017 it is say around 550. In 2018 this one is 500. And if you are looking at the 2019, let me first scroll it down a bit here. So if you are looking at the 2019 number for finance, that is this one, is close to 280. Now if you are looking at tech, that is the orange reddish line. In 2016 it is close to 320. This is tech. In 2017 it dropped a lot, it has come to around 80. In 2018 it is over here, so this is close to 720. In 2019 it has dropped a lot, so let us assume that it's roughly 20. Now if you are looking at the marketing one, initially it started very high, it is 1100. Then it fell a lot in 2017 to just less than 400, so let us assume it is 380. Now in 2018 it has gone above 600 but less than 700, so let us assume it is 650. And in 2019 it is close to 200 but just above 200, so let us assume this is 220. So these are the two tables that we have. Now based on these two tables we will have to figure out which of them is x, which of them is y, and which of them is z. One of the key things that we will have to look at is the outlier. Over here the outlier is the salary of marketing in 2016. It is extremely high, so that is this 1100. Now if the individual salary of marketing is say 6, the number of employees in marketing will be 1100 by 6, so that is roughly around say 200, it will be around 180. But that is not possible because we know that in each of these years all the employees are less than 130. All the employees in each of the departments is a distinct multiple of 10 less than 130. So it can't be 6. So if it is say 4.2, again 1100 by 4.2, you will get something close to say 250. That is also not possible. So we know for sure that Z is marketing, because if you are dividing 1100 by 10, you will get 110, which is a distinct multiple of 10 less than 130. So we know that Z is marketing. Similarly, if we are looking at Y, 4.2, 320 is roughly fine because that is around 80, we don't get any information. 3.8 and 80 is say around 20, that is also okay. 6 and 720 is also okay because this is 120, still fine. And if you are looking at the last one, that is 2 and 20, this is 10. So again you can see that if you are looking at 2, this is an interesting number to look at, because if you look at the 2019 numbers for finance, tech and marketing, because we don't need to consider marketing because we have already concluded that marketing is Z. If you are looking at 2019, we know that the individual salaries of Y is 2 units and the total salary is either 280 or 20. Now if it is 280, it would imply that the number of employees in department Y is around 140. This is not possible. So once we know this, we can conclude that Z is tech, because 20 by 2 is 10, which is possible, but 280 by 2 is 140, which is greater than 130. Now so this would imply that X is finance. This is something that we know. Now based on these three, let us try to understand the distribution of the number of employees in each of these departments. We know that the employees are distinct multiples of 10. So they are either 10, 20, 30, till 120. Now let us try to put them in this tables. Let us take the tables down, draw a new table which is number of employees. We'll again draw finance, tech and marketing. We'll again write down the different years: 2016, 2017, 2018 and 2019. Remember that there are a total of 12 blanks to fill here, and we know that each of the blanks are 10, 20, dot 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 till 120. We just need to understand where we can fill each of them. Now for this we have the data over here. We know that the number of employees in marketing in 2016 is 110, because that is 1100 by 10. So let us first fill that up. This is 110. Similarly, we know that the number of employees in tech in 2018 is 720 by 6, which is 120. These are the outlier numbers which we can easily fill. This is 120. Similarly, the number that we use to determine which department is tech is the number 20. 20 by 2 is 10. So we know that this is 10. Now let us try to see what else we can put. 2.5 and this is 220. So this seems like roughly 90. That is the number of employees in Z, that is marketing in 2019. The average salary, the individual salary is 2.5 and the total salary we put is to be approximately 220. But if you actually make it 225, then the number will be 90. So we can put the number here as 90. Similarly, if you go, the first one, that is the individual salary in X is 6, that is this in 2016, and in finance the total salary is around 250. So clearly 6 and 250 would imply that the number of employees is 40, and this is not 250 but this is equal to 240. So we can go there and fill up 40. Now if you look at the numbers which are remaining, it is 20, 30, 40 is done, 50, 60, 70, 80, 90 is done. We need 100, 110 and 120. Let us try to see where we can find 100. If there is a number where the ratio is roughly around say 100. Now we can see that in 2018 in marketing, that is this one, in 2018 Z, this is around 6.5, and we also know that the total in marketing is 650, that is this one, this number. So we can imply that this is 100. So we can cross this off. Now let us try to see where we can get 20 or 30. We will go with the ones which are most obvious. So the ones which are much lesser cluttered are the ones we should try to fill up first. Now if you are looking at 20, you can see that there is 3.8 here and 80 here. So 3.8 into 20 is 7.6. So this is properly 3.8 and this is 76 and not 80. So you can put this as 20 and let us cross off 20. Now let us see where we can find 30. This is 9 and this is 280. So 9 and 280, again the ratio is close to 30, it is close to 31. So probably instead of 280, this was actually 270. This is also gone. Now if you are looking at something like where we can find 50, you will see that this is 7.5 and this is 380. 7.5 into 50 is 375. So probably this is not 380, this is probably 375 and this is 50. Now let us see where we can get 60. You can see that this is 8.2 and this is 500. 8.2 into 60 is 492. So probably this is not 500, or probably this is not 8.2, maybe this is 8 and this is 480, or maybe this is 8.5 and this is 510 roughly. But do you know that the number of employees is 60 here, because the ratio is not going to change much. Now if you are looking at where we can find 70 and 80, there are only two blanks left. This is 4.2 and 320 is roughly 80 or 70. This is interesting. And if you are looking at the second one, this is 550 and 7. This is also can be either 70 or most probably this is 80. So if you look at the actual number again, X, let us clear this off. X in 2017 is this one. This is definitely very close to 7. And if I am looking at Finn in 2017, that is Finn in 2017, this number is again close to 550. So if you are looking at it, 550 by 7 is definitely much closer to 80 than it is to 70. So I'm going to put up 80 here, and for 70 I will once again cross check the numbers for Tech in 2016. Tech in 2016 is just above 300, so it will be possibly around say 310. This is the number just above 300. Now if I am looking at the first blank, I will have to look at the value of y in 2016. The value of y in 2016 is somewhere over here. Value of y, this is greater than 4 but less than 6, something like say 4.2, probably it was slightly higher, probably it is say around 4.5. And in Tech in 2016, so this is Tech in 2016 is this one. This one is very close to 300, just slightly above it. So this is say roughly around 310. Now if you look at 4.5 into 70, you will get is to be roughly close to 4.5 into 70 will be roughly 315. So probably this is 70. So now what we have done is we have drawn the tables and we know the exact distribution of the number of employees in each of these years. You can see that all these 12 blanks have 12 different numbers from 10 to 120, which are multiples of 10. Now we can easily answer the questions that are asked. If you are looking at the first question, X in the first graph represents which department? We have answered this here. X is finance. So if you are looking at the options, X is finance. Now if you go to the second one, how many people belong to the finance team in 2016? We have already drawn the table. So if you come down, in finance in 2016 is 40. So I don't know why the answer is not there, but the answer is say 40. Now the third one is, what is the total number of employees in all three departments in the year 2017? Now if you look at 2017, the total will be 80 plus 20 is 100, 100 plus 50 is 150. So the answer will be 150. Now let us look at the last one. There are 4 statements given and we have to find out which of the 4 statements is correct. Marketing department has the most number of employees in the year 2018. If you look at 2018, the answer is Tech. Tech has 120, which is the highest. So option A is wrong. If you are looking at option B, total number of employees across all departments in 2017 is less than that in 2019. So if you look at 2017, the total number of employees, as you have just calculated, is 150. In 2019, the total number of employees is 130. So the number of employees in 2017 is greater than 2019. And the option is total number of employees across all departments in 2017 is less than that in 2019. So this is also wrong. If you look at the third one, technology department has the most number of employees in the year 2018. In 2018, technology, we have just found out, has the most number of employees. So this is correct. The last one is marketing department has the most number of employees in the year 2017. If you come down in 2017, the answer is finance. 8 is the maximum in this year. So option D is also wrong. Therefore, the correct option is option C. Now to answer this kind of a question, the important thing is figuring out the distribution of the number of employees in each of the departments across the 4 years. You have the approximate numbers based on the graphs that are given and you have to find out the exact number of employees. Once you find that out, solving all 4 questions is very straightforward and you can solve them very fast.
Hi friends, welcome to Krako's video series. I am Saili Kale. In today's video, we are going to take a look at the following LR set, which is based on truth layer plus seating arrangement. So let's take a look at the set first. 8 students are sitting around a circular table position 1 to 8. There are 2 types of students, type 1 student, type 1 whose statements are true and type 2 whose statements are false. So essentially type 1 is truth teller, type 2 is liar. They made 8 statements in the order of their positions alternating between true and false statements. So it's basically true, false, true, false, true, false, or false, true, false, true, false, true as such. So another information that is known is Sandeep is positioned at 5, Radha is one of the students, and then the statements are given. When asked about the positions, the following statements are made in the given order. Position 1, I am Anu and I am type 1 student. Position 2, Rinesh is type 1 student. Position 3, Shruti sits opposite to me. Position 4, Anu, a type 2 student, sits opposite to me. Position 5, Arya and Deepika sit next to me. Position 6, Rinesh sits opposite to me. Radhika, position 7, Radhika sits opposite to me, and position 8, Deepika is one of the neighbors of Anu. So these are what we know, and we know that the true and false positions alternate, that is type 1, type 2 alternate. So there are two basic this. First is that it is true, false, true, false, true, false. That is the first position is type 1, second position is type 2, third position is type 1, and so on. And the second possibility is that first position is type 2, second position is type 1, third position is type 2, and so on. So we will consider both those cases till we come to a contradiction. So consider the following this. So one possibility is this: 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay. We know that in both positions Sandeep is at 5, so I can put that down. Okay, so this is done. Radha is one of the students, we will keep that for now. So type 1 and type 2 alternate. So in this particular I'll say that so this person is type 1, this person is type 2, this person is type 1, this person is type 2, this person is type 1, this person is type 2, this person is type 1, this person is type 2. Okay. In this case, this person is type 2, this person is type 1, this person is type 2, this person is type 1, this person is type 2, this person is type 1, this person is type 2, this person is type 1. This is the two possibilities that exist, given that we know that they alternate between true and false statements. Okay. So now that you know all of this, let's go on to the actual statements. So in the first case, let's try to place people, and in if we come to a contradiction, we'll stop. Okay. First position, I am Anu and I am a type 1 student. Here it is type 1, so there is no contradiction. So this person would be Anu. This statement would be a true statement, so this person is Anu. Position 2 would say that Rinesh is a type 1 student. This would be a false statement, so that would indicate that Rinesh, I'll just put it to this. So this is case 1, case 2. Okay, Rinesh is actually a type 1 student then, because is actually a type 2 student then, because this person is lying. Okay, so this statement is false, which means that Rinesh is a type 2 student. Shruti sits opposite, this person is telling the truth, and he says that Shruti sits opposite to me. So 7 would be Shruti, this person is Shruti. Anu, a type 2 student, sits, fourth person is lying, and he says that Anu, a type 2 student, sits opposite to me. Now clearly that Anu doesn't sit opposite to him, and she is a type 1 student, so this is a lie, so we can ignore that. Fifth person is telling the truth. He is saying that Arya and Deepika sit next to me, so this should be Arya or Deepika, and this should be Deepika or Arya. Okay. Sixth position says Rinesh sits opposite to me. Now since she is lying, then that means that Rinesh cannot sit over here. But we know that Rinesh is a type 2 student, so he has to sit in a position which is for a type 2 student. So the only two places for type 2 student are now left are 8 and 2, because these two are taken by Deepika and Arya. So if he is not seated at 2, that means that he is seated over here. So Rinesh sits over here. Radhika sits position 7. This person is telling the truth. So she says that Radhika sits opposite to me. So at position 3 we have Radhika. Okay. And position 8 says Deepika is one of the neighbors of Anu. And that is clearly a lie, because Deepika is over here. So that is definitely a lie. So we have not come to a contradiction in this case. In this case, if we follow this particular we come to this particular configuration. You have Anu over here. Since Radha is one of the students and she has not been placed, this person would be Radha. Okay. So we have Anu over here, Radha over here, Radhika over here, Deepika or Arya over here, Sandeep over here, Arya or Deepika over here, Shruti over here, Rinesh over here. So we get this case complete in this particular case if we get true, false, true, false, true, false kind of thing. Now the second case is false true, false true. So let's take a look whether we can fit another, we get another possible case using that. So when asked about, okay, so we start with the first position. I am Anu and I am a type 1 student. So this person is lying. So this is either not Anu or Anu is not a type 1 student. So one of the two would be a lie as such. It could be Anu, but she is a type 2 student. So you don't know which part of it is a lie. So we'll keep it for now. The second position is telling the truth, and that person says Rinesh is a type 1 student. So I can infer that Rinesh is type 1 because the second person is telling the truth as such. The third person says Shruti sits opposite to me. So this is Shruti does not sit opposite to 3. So therefore this can't be Shruti. Okay. Then the fourth person says that Anu, a type 2 student, sits opposite to me. Now this person is actually telling the truth. So Anu will have to sit here and she'll have to be a type 2 student. But which can't be, because if this person is a type 1 student, this one also has to be type 1 because they sit alternately. So Anu, a type 2 student, cannot be seated over here. So we come to a contradiction. This fourth statement cannot be true. It has to be a false statement because the liars sit opposite to each other. If you can see, all the truth tellers are sitting opposite to each other and all the liars are sitting opposite to each other. So if this person is telling the truth, then if Anu is sitting opposite to him, that person, Anu can't be a type 2 student then. Anu has to be a type 1 student because if she is sitting opposite to him and he is a truth teller, then she has to be type 1 also. So clearly this is a contradiction and therefore this case cannot exist. So we can eliminate this case. This is the only case that actually exists. So I can eliminate this case as such. So now that we have gotten only one case and a possible seating configuration, let's go to the questions now. So let's go to the first question. Who is seated at position 6? So at 6 we have Arya or Deepika. So answer is cannot be determined. So one of the two is seated at position 6. Let's take a look at the second question. How many arrangements are possible? So one arrangement is Arya here, Deepika here, and the second arrangement is Deepika here, Arya here. So there are two arrangements possible. So the answer to this is 2. So let's take a look at the third question. The third question is, who among the following can be seated opposite to Arya? So if Arya is seated over here, then Radha can be opposite to her. And if she is seated over here, then Rinesh will be opposite to her. So either of Radha or Rinesh can be seated opposite to Arya. So among the given options, Rinesh is there. So Rinesh would be the one who can possibly be seated opposite to Arya. So the right answer is option A. Now the fourth question is, which of the following statements is definitely true? The first statement is Arya is seated at position 6. We don't know whether she is at position 6 or 4. So we can't say it is definitely true. Arya is a type 2 student. Yes, this is definitely true. Whether she is at 4 or she is 6, she is definitely a type 2 student. So this is definitely true. Sandeep is one of the neighbors of Anu. That is not true. Anu's neighbors are Rinesh and Radha. So clearly this is a false statement. Rinesh and Anu are type 1 students. Rinesh is type 2, Anu is type 1. So even this is a false statement. So only option B is definitely true. So the right answer is option B. So this is how we solve the given LR set. As you can see, this is a pretty simple LR set once you make the cases, and once you started drawing it out and placing people, it became easier to do. Always try to remember that in even truth layer arrangements, it's arrangement that you have to do. So you have to draw the arrangement cases as such. The representation format that you have to follow is that of arrangement. So even if it's a truth layer arrangement, try to follow the format of arrangement questions as such. So now that you know how to solve this particular LR set, please go to the study room and keep practicing. The more you practice, the better you're going to get. Hi friends, welcome to Krako's video series. I'm Saili Kale. In today's video, we are going to take a look at the following LR set, which is based on picking coins, or in this case picking marbles from a table. So we have done a video on how to solve that in general. In this case, we'll take a look at this LR set and try to follow those particular rules. So let's take a look at the LR set. Rinesh and Rinsha have 150 marbles on the table. Each of them takes turns to pick marbles. They can pick at least 2 and at most 6 marbles in each turn. It is known that both of them play intelligently. if after Rinesh's turn there is only one marble left on the table, then Rinsha will pick that one marble. The same is true for Rinesh also. So if there is one marble, you have to pick up one marble. If there are two marbles, you have to pick up the two marbles, and you have to pick between 2 to 6 marbles as such. So if there are 7 marbles, you can pick 6 marbles and leave one marble as such. So that is the basic rules. Now there isn't any question that you can solve, like anything that you can do right now. You will have to solve this on the basis of the questions. So let's take a look at the questions. Consider the following question. Rinesh picks the first marble and the person who picks the last marble is the winner. What is the number of marbles that Rinesh should pick in the first turn to ensure his win? See, the person who picks the last marble is actually the winner. So you have to identify what are the winning positions, and you have to essentially identify what are the losing positions, and Rinesh should pick those many number of marbles in such a way that he pushes Rinsha into a losing position. So there are some positions where the number of marbles on the board are such that you would always lose if both players play in a rational manner, and there are some number of marbles on the table where one player will always win if both play rationally. So we have to figure out what position is a winning position, what position is a losing position. Once we figure that out, we will understand what Rinesh has to do as such. Okay, so let's consider what is the winning position first. See, if there is one marble on the table, it's a winning position because you'd pick up the marble and the last person to pick it up would be the winner. Similarly, if there are 2 on the table, you'd pick both of them and you'd still be the winner. If there is anything from 1 to 6, you'd pick up all those marbles, and because you are the last person to pick up the marbles, you'd be the winner. So 1 to 6 is a winning position. Now suppose you have 7 marbles, okay. Now if you have 7 marbles, no matter what you pick from 2 to 6, you will be leaving somewhere some value between 1 to 6. So if you have say 7 marbles, suppose you pick 2, you'd be leaving 5, the next person will pick all 5 of them up and win. Suppose you pick 3, you'd leave 4 marbles and that person will pick up all 4 marbles and win. Suppose you pick all 6, the max that is allowed. Even in that case, you will be leaving 1 marble which the other person will pick and then he will win. So 7 is a kind of position which you cannot win from. 7 is a must-lose position essentially. So 7 is a losing position. Similarly, consider the case for 8. Now in case of 8, if you pick 2 marbles, how many marbles do you leave on the table? You leave 6, which is a winning position. If you pick 6 marbles, how many marbles do you leave on the table? You leave 2, which is also a winning position. So no matter what you pick from 2 to 6, you are leaving your opponent in a winning position, which means that 8 is a must-lose position. So 8 is a losing position. Now let's come to 9, okay. If you have 9 marbles on the table, what will you do? You will pick up 2 marbles and you will be pushing your opponent to a must-lose position. So 9 is a will always logically win kind of position. So 9 is a winning position. Same with if you have 10, you will pick up 3 marbles and put somebody in 7. Suppose you go up to 10, 11, 12. Similarly, you will keep picking till you push somebody till into the must-lose position of 7. 7 plus 6 is 13. So if you have 13 marbles, you will pick up 6 and you will push somebody into 7. If you have 14, you will again pick 6 and you will be pushing them into 8, which is also a must-lose position. So 9 to 14 are winning positions. Now 15 onwards, if you see 15, what can you pick? You can pick 2. If you pick 2, you get 13, which is a winning position. If you pick 6, you get 9, which is also a winning position. So 15 is one of those losing positions where you can't do anything without putting your opponent in a winning position. Similarly, if you have 16, you pick 2, you put your opponent at 14, which is a winning position. If you pick 6, you put your opponent at 10, which is also a winning position. So 15, 16 are always losing positions. Now again from 17, if I have 17, I'll pick 2, I'll put the person at 15 and I'll put my opponent in a losing position. So 17 is a winning position. Similarly, 18, 19, I'll continue to do that. Okay, so till from 18, so 15 plus 6 would be 21. So at 21, I'll pick 6 marbles, I'll put the person at 15 and it would be a losing position. At 22, again I can pick 6 and I'll put them at 16, which is always again a losing position. So 17 to 22 is a winning position. Now see, we see a trend emerging, okay? 7, 8 are losing positions. 15, 16 are losing positions. In this case, the next would be 23, 24. Okay, these are losing positions. So can you see a general pattern emerging? This is 8, 16, 24 as such. And this is basically of the general format 8x minus 1 and 8x. Whenever the number of coins on the table are of the form 8x or 8x minus 1, it is a losing position. Now Rinesh has to win. Now if Rinesh wants to win, he must make sure that the number of coins on the table should be either of the form 8x minus 1 or 8x. Okay, so you have 150 coins. Now what is the number of coins in that he can leave on the table? If he, so you have to find what is the nearest multiple of 8 of the form 8x minus 1 or 8x near 150. So if it is 150, what is the multiple of 8 which is closest to 150? That would be 144. 144 is closest to 150. So if he leaves either 143 coins on the table or 144 coins on the table, that person, the Rinsha, would be in a forever losing position. So he has to put, because he can't remove 7 coins, he can max remove 6 coins. He has to remove 6 coins and leave 144 coins on the table so that Rinsha always loses. So Rinesh should logically pick up 6 coins, leaving 144 coins on the table so that he always wins. Okay, so this is how we solve the given question. Now let's take a look at the second question. Rinsha picks the first marble and the person who picks the last marble is the loser. What is the minimum number of marbles that Rinsha should pick in her first turn to ensure her win? Okay, so we now have that the condition is reverse kind of. So 1 and 1 to 6 is the, 1, if you have 1 marbles on the table, you have to pick it up and you would be the loser. So 1 is now a losing position. Similarly 2 also, you have to pick up 2. If there are 2 on this, you can't pick up 1. So 2 is also a losing position. Now 3, if you have 3 on the table, what will you do? If you have 3 on the table, you will pick up 2 and you will leave 1 for the opponent and he'd be in the losing position. So 3 is actually a winning position. Similarly, if you have anything from 1 plus, if you put 1 plus 6, that is 7. So 7, 3 to 7, if you have 7, you would pick up 6, you would leave 1 on the table and the opposite person would lose. Similarly, if you have 8, you would pick up 6, you would leave 2 on the table and the opposite person would lose. So 3 to 8 are winning positions. Now let's take a look at 9 and 10. If you have 9 on the table, you pick 2. You leave 7 on the table, that is a winning position. Similarly, if you pick 6, you would leave 3 on the table, which is also a winning position. So if you have 9 coins, 9 marbles on the table, no matter how many marbles you pick, you will leave your opponent in a winning position. So 9 is a must lose position. Similarly with 10, if you pick 2 coins, you leave 8 on the table, which is a winning position. If you pick 6, you leave 4 on the table, which is a winning position. So 9 and 10 will, 9 to 10 is both are must lose positions. Similarly, you will get this plus 6 is 16. Okay, so if you 11 to 16, you have if you have any position between 11 to 16, you can put you can pick marbles in such a way that you put them in the 9 to 10 category, which is a must lose position. If you have 11, you will pick 2, that person will go to 9. If you have 16, you will pick 6, that person will go to 10. If you have 12, you will pick 3. If you have 13, you will pick 4 and so on, so that you can always push your opponent to the must lose position. So this is a must win position. So again 17, 18, following the same, this would be a must lose position. So you see a pattern emerging. What is the pattern? So 1, 2 is a losing position. 9, 10 is a losing position. 17, 18 is a losing position. So what is exactly the format? This is 8x plus 1 and 8x plus 2. So 8x plus 1 on the board or 8x plus 2 on the board, where essentially x can go from 0 to any n number, is of the form of, is definitely a losing position. Now Rinsha has to put her opponent in a losing position. So she has to leave that many marbles on the table such that it is either 8x plus 1 or 8x plus 2. So she starts with 150 marbles, okay. So what is the nearest multiple of 8? That is 144. So she should leave either 145 or 146 marbles on the table. Of this, what is the minimum number of marbles that she should pick? In this case, she should pick 5 marbles. In this case, she should pick 4 marbles. So the minimum number of marbles that she should pick to ensure her win is 4 marbles. So the answer over here is 4. So consider the third question. If the number of marbles left on the table after a person's turn is less than the minimum number of marbles that a person can pick, then the game ends. Dinesh picks the first marble and the person who picks the last marble is the winner. What is the minimum number of marbles that Dinesh should pick in his first turn to ensure his win? So what does this mean? This means that if there is 1 marble on the table, then the game has ended and the person picking the 1 marble would not be the winner because they can't pick up the 1 marble. So if there is 1 marble on the table, that is actually a losing position because the person who just picked would be the winner. So 1 is the losing position and 2 is the winning position. 2 is also 2 is winning position and 2 to 6 would be a winning position. So in this case, as we had done in the first case, we had 1 to 6 which was win, but in this case it is 2 to 6 which is win, okay. So 2 to 6 is a winning position. Now consider 7. If you have 7 on the table, what you will do is you will pick up 6 and you would leave 1 for the opponent. So if you pick up 6, that means that you are leaving only 1 for the opponent and he can't pick that up, so you are winning. So even 7 is a winning position. Now let's consider 8. If you have 8 if you pick 2, you leave 6 which is a winning position. If you pick 6, you again leave 2 which is a winning position. So 8 is a must lose position. Now let's take a look at, if you, 8 is a must lose position. Now let's consider 9 marbles on the table as such. If you have 9 marbles on the table, then if you pick, you can't pick 1 marble. So you have to pick 2 marbles and you leave the position at 7 which is a winning position. If you pick 6 marbles, you put it at 3 which is again a winning position. So 9 is also a losing position. So now it has actually shifted from 7-8, it has become 8-9. Now consider 10. Now if it is 10, what I can do is I can pick 2 and I put my opponent in a losing position. So 10 is actually a winning position. Similarly, if I have 8 plus 6 that is 14, I can put my opponent in a losing position. 9 plus 6 which is 15 also I can put my opponent in a losing position. So 10 to 15 would be winning positions. So 10 to 15 is winning. Now consider 16. 16 if I choose take 2, I put the person in this category so he'll always win. If I take 6, again I put them in this particular bracket so that my opponent will always win. So 16 is always a losing position. Similarly, 17, if I pick 2, the person will win because if you fall in, he'll have 15 coins, that opponent will always win. Similarly, if I pick 6, I'll leave 11 which again falls in this category. So 17 is an always lose position. So 16, 17 is a losing position. This is 18 to this plus this, so this is 23. So 18 to 23. If I have 18, I'll pick 2 coins and leave 16 on the table and my opponent will always lose. If I have 23, I'll pick 6 coins and my opponent will have 17 and he'll always lose. So between 18 to 23, I'll always win. So this is a winning position. Now comes 24. If I have 24, if I pick 2, I'll put my opponent in a winning position. If I pick 6 also, I put my opponent in a winning position. So 24 is an always lose position. Similarly with 25, if I pick 2, 23 is an always winning position. If I pick 6, again 19 is always winning position. So 24, 25 are losing positions. So what is the general format? 1 is losing, 8, 9 is losing, then 16, 17 is losing, then you have 24, sorry, this is 24, 25. 24, 25 is losing. So 8x and 8x plus 1 are losing positions. So what is the nearest multiple of 8 below 150? That is 144. So 144 is a losing position and 145 is a losing position. So if he has to pick the minimum number of marbles, in this case he has to pick 6 marbles, in this case he has to pick 5 marbles. So what is the minimum number of marbles he has to pick so that he ensures his win? He has to pick 5 marbles to ensure his win. So the right answer is option B, 5. Let's take a look at question 4. If the number of marbles left on the table after a person's turn is less than the minimum number of marbles that a person can pick, then that person has to pick all the coins. Rinsha picks the first marble and the person who picks the last marble is the loser. What is the minimum number of marbles that Rinsha should pick in her first turn to ensure her win? So in this case, if you have like say 7 marbles on the table, you can't pick 6 and leave 1. You'd have to pick all 7 of them just because you can't leave 1 on the table and you'd lose. So what does this mean? This means that one marble on the table case doesn't exist. So you have to start from 2. So if there are 2 marbles on the table, you are a loser for a losing position for sure because you have to pick both of them up. If you have 3 marbles on the table, again you can't leave 1. So 3 is also a losing position because you can't pick 2 and leave 1. So you have to pick all 3 of them. So it is a losing position always. If you have 4 marbles on the table, you can pick 2 and you can leave 2 for your opponent, which puts them in a losing position. So 4 is a winning position. Okay. Similarly, if you have 5, you will pick 3 and you will put the person at 2. If you have 6, you will pick 4 and you will put person at 2 and so on. Till 9. When you have 9, you will pick 6 and leave the person at 3, which is a must lose position. So 4 to 9 would be a winning position. Now if you have take a look at 10. If you are at 10, if you pick 2 coins, you are putting them in the winning category. If you pick 6 coins, you are again you're leaving 4 on the table and you are again putting them in the winning category. So 10 is a must lose position. Similarly, 11, if you pick 2 coins, you leave 9 coins on the table, which is a must win position. If you pick 6 coins, you leave 5 coins on the table, which again is a must win position. So 10, 11 are losing positions. Okay. Now you come to 12. Okay. If you come to 12, what you can do is you can pick 2 coins and put your opponent at 10, which is a must lose position. So 12 is a winning position. Similarly, 11 plus 6 would be 17. From 12 to 17, you can always pick in such a way that you put that person in the 10 to 11 range. So at 17, I'd pick up 6 coins and put him in the 10 to 11 range. At 16, I'd pick up 5 coins and put that person in the 10 to 11 range. So 12 to 17 is a winning position. 18 again, if you have 18 coins, if you pick 2, you put them in the winning position. If you pick 6, again you put them in the winning position. Similarly, at 19, whether you pick 2 or 6 or anything in between, you would put your opponent in the winning position. So this is these 2 are losing positions. Now we come to, so next would be 20 to 25, which would be winning positions because you can always put them, your opponent in this particular band. So 20 to 25 would be a winning position. Next would be 26 to 27, which would be losing positions. Okay. So we see a general format that is forming. So 2, 3 are losing. 10, 11 is losing. Then you have 18, 19, which is losing. 26, 27, that is losing. So what is this? This is 8x plus, I'll just write over here. So this is 8x plus 2, which is a losing position, and 8x plus 3, that is a losing position. So 8x plus 2, 8x plus 3, 8x plus 2, 8x plus 3, 8x plus 2, 8x plus 3. These are all the losing positions. Now these are the must lose positions, and Rinsha has to pick the first marble, and the person who picks the last marble is a loser. So how many should, if this is the case, what is the number of this that she should leave on the table so that she wins? So there are 150 to begin with. Nearest multiple of 8 is 144. So this would be 146 or 147. Now if she has to pick up the max number of this, she has to in this case pick up 4. If she has, and in this case she has to pick up 3. So the max number of coins that she can pick up is 4 to ensure her win. So the right answer is option C, 4. See, in this case, as you can see, once we write down what is the winning position and losing position, in each case there is a clear pattern that emerges, and once you see that pattern, it becomes very trivial to solve the question. This question is lengthy if you actually have to explain it out, but once you solve the first question and you see how you have to solve it, it becomes fairly easy. You can easily do this under 10 minutes if you understand how to distill it down to saying, okay, this is a winning position, this is a losing position, this is a general format. Once you get to that, it would become an easy question to solve. So always remember, in these cases, in the number of picking coins cases, you have to immediately identify what is a winning position, what is a losing position. Once you do that, it's a pretty simple LR set to solve. So this is how you solve the given LR set. Please go to the study room and keep practicing. The more you practice, the more you will know how to solve LR sets. Hi friends, welcome to Krakow's video series. I'm Saili Kale, and today we are going to look at an LR set based on cubes. This is a slightly lengthier LR set and it would require us to draw quite a bit. So this is kind of based similar to the 2D space LR sets that have come in CAT in the recent years. So this is important that we know how to solve these kind of sets. In these kind of sets, first read the question, then see what the questions are, and that will help you decide what exactly needs to be solved. Once you know what exactly needs to be solved, then you can proceed with answering the question. So let's first take a look at the instructions that are given. 8 into 8 into 8 cube is numbered in such a way that in the lowermost layer, the first row is numbered 1 to 8 from left to right, and the next row is numbered 9 to 16 from right to left, and so on. The next layer is numbered such that the cube numbered 65 is just above the cube numbered 1. This way the cubes are numbered till 512. Now the faces of the 8 into 8 into 8 cube with cubes numbered 9 and 16 are painted in blue, and the rest are painted red. So we have an idea of how the cube looks. So basically, so this is the cube. So you have the bottom layer which is 1 to 8, and this is like the bottom face which is painted blue. Then above that you have another face and all, and this bottom face I'll just draw quickly. So this bottom face is, okay, I'll draw a bigger one because I'm going to need some space to draw. Okay, so this is the bottom face which is painted blue. So that is numbered, say 1, 2, 3, 4, 5, 6, 7, 8. I'll not put in all numbers because that's not necessary. And then the next number is 9, 10, 11, 12 to 16. Okay, so that is how the this is numbered, and this goes on till this will become 17. This will become 17 to this will be plus 8. So this would be 17 to this plus 8. So that is 20. This plus 7, so this plus 7 would be this would be 24, this would be 25, this would be plus 7, so this would be 32, this would be 33, plus 7 40, 41, plus 7 48, this is 49, plus 7 this is 56, this is 57, and this would be 64. So this is how the bottommost face is numbered. So this is, if I can show on the screen, this is 1, this is 9, and this is 16 over here. Okay, sorry, not 9 and 16. Sorry, I'll just, that's not on the top layers, but this is 1 over here, this is 9 at the bottom face only, and this is 16 at the bottom face. Now since the faces containing 9 and 16 are also colored blue, this means that this face over here, which is like on the side, this face will also be colored blue, and similarly this face over here at the back will also be colored blue, because the cube 16 sits over here, so it sits on the side as well as bottom. Similarly 9 sits over here, it sits on the side as well as bottom. So basically the bottom side and the two sides are painted blue. The front face, top face and back face are painted red. So this is the information that is given to me till now. Now before I try to solve the question, let me first take a look at the questions that are asked so that I know exactly to what extent I have to solve. So let's take a look at the questions. the sum of the numbers on the face diagonal of the cube face having numbers 8 and 505 on it can be. So I have to find out the face diagonal, sum of the numbers on the face diagonal of a particular cube face that is given. Second, number of cubes which are painted only in blue is, so for this I don't need to calculate anything. I can find out the number of cubes which are painted only in blue without considering the numbers that are there on each of the individual cubes. So this is pretty easy as such. The sum of the numbers on the cubes which are painted on three faces is, this would require me to consider the individual numbers. So this is again requires a bit of calculation. And the last one is the number of cubes which have at least two sides painted is what. So again, this does not require me to consider how each individual unit cube is numbered. The second and fourth question are just plain questions on cubes. You can solve them without even considering the numbering of the unit cubes as such. But let us solve the entire set. For solving the entire set, firstly I will do what is needed for me to solve the first question, that is sum of the numbers on the face diagonal of the cube face having 8 and 505 can be. So where will this face diagonal be exactly? So if we consider, so this 8 is over here, okay, so if we consider it, this 8 is over here, and where would 505 be? So the next level is basically 65. So if I consider this is the bottom face, now I have to consider essentially this face over here, okay, this face where this is the bottom face, so I have to essentially consider the face, blue face over here, okay, on the right side of the cube. How does that blue face look? Because 8 sits on that particular corner. So 8 sits on the bottom cube, 8 sits at the bottom, 8 sits in the front, and 8 sits on the side. Now I want the blue face, I want to see the blue face where 8 is, because what is asked for me is sum of the numbers on the face diagonal of the cube face having 8 and 505. So this does not have 505, so the bottom face doesn't have 505. It can be either the front face with red, which has 505, or the side face with blue, which has 505. So let's figure out which one of it is. So let us consider, now if it is the front face, okay, in the front face, each layer, as we go up each layer, I'll just actually draw that. So as we go up each layer, this is 1, this is 65, then the third layer would be 65 more, so that would be 128. Now the next up layer would be another 65, so that would be a pretty, that is the layer which has, would this layer has 505, I'm not sure. The other layer is over here, which is 8 and has 8, 9 and this entire content in it. So let's figure out which of these two faces we are considering, and then we have to calculate the face diagonal for it. Okay, so let me actually first make enough area for me to have both faces, and once I figure out which face will have 505, then it will become easier for me to consider which face I have to completely fill out. Okay, so let me see this is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, oh no, sorry, one more. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the other face I will draw over here. Actually, I don't have a whole lot of space. So instead of, before I fill out things, I'll just try to figure out what the corners are so that I can get a guess of what the faces will be. This is just ignoring everything. I'll just try to figure out what the corners are for this face and the front face. Okay, the front face has 8 over here. Okay, and it has 1 to 8 over here. The next level is 65. This will be 8 plus 65. This will be, so essentially it would be 1 plus 65, 2 plus 65, 3 plus 65 and so on till 8 plus 65 is 505 on this level. Let me try to figure that out. So 505, how can I write it as 64 times something plus 1 to 8? If I can write it out, then it will be in the front face. If I can't write 505 in that terms, then it will be in the side face. So 505 divided by 64 is what? So 505 divided by 64. So I can say that 320 320 would be 5 times. Next would be 384. Next 64 would be 428, and next 64 would be 492. So 492. Okay, so the closest one to 505 is 492. So 505 is essentially 5, 6, 7, 8. 8 times 64 plus this is 13. So this it cannot be expressed as 64 times some number plus 1 or 2 or 3 or 8. So it will definitely not be on the front face. Therefore, it must be on the side face. So let me actually fill out how that side face will look like, and then I have to calculate what is the sum of the numbers on the face diagonal of that face. Okay, so let me see that number. So this is on the side face. The side face, the bottom part would be 8, 9. This layer, this row will be basically 8, 9 and 24, 25, etc. So I can start off by putting those numbers in. So this is the bottommost layer and it is over here. Okay, so this is how it will look like. Now that I have figured out this is what it is. Now what would the next layer be? Each layer will be basically this layer plus 65. So this next would be basically 8 plus 64, so that would be 72. But I just need all the elements that are there on this particular diagonal and this particular diagonal. Once I get that, then I can answer the question. So I will ignore all the elements other than those on the diagonals. Okay. So I need basically for the diagonals I need 9 plus 64, that is 73. So now I have to find the next number on the diagonal, so that is about 24. So first I add 64 over here, so that is 137. So this is 137. The difference between these two is plus 15. So this is 137 plus 15 is 152. Then again I add 64, so I get 64 is 16, 216 plus 1 would be 200. And next if I go up again I'll have to add 64, so that would be 6 would be 11, so this would be 8, so this is 281. So this is so the next number is basically this is 282. Oh no, I have to put plus 15, so this will not be 282, this would be so essentially you have to continue the same jump that is observed. This is plus 1, so I am doing plus 1. If this is plus 15, then I have to do plus 15. In this case I have to do plus 15, so this would be 296. Again plus 64 to go up to the next level, so this would be 360, and this is plus 1, so this is 361. Again to go up I would be plus 64, so this is 5, plus 60 would be 425. This is plus 15, so this is 440, and again to go up this is 404, so this would be 505. So this is the face that is being asked, 8 and 505 on it. So this is the face. So I have calculated the numbers for the right face. Now I have to, this is one face diagonal, the other face diagonal is over here. Now let me see what is being asked. The sum of the numbers on the face diagonal of the cube face having 8 on 8 and 505 on it can be, and there are some options given, which is the options are 2042, 2052, 2049 and 2050. Okay, so if I get I have already filled out one diagonal. If I get any of these following options, then I can directly just tick the right answer. So let me calculate what is the sum of the numbers on this particular diagonal. So that is 8 plus 73 plus 152 plus 217 plus 296 plus 361 plus 440 plus 505. So if I try to take it, this is 81, this is 233, this is 233, this is 250, 450 plus 300 minus 4, so 750 minus 4, so that is 747 so 747 plus 360 plus this would be basically 800 plus 505. So what would the sum be? This is sum would be 1547 plus 505. So this is 252. This is 2052. So this sum of the elements on this diagonal of the numbers on this diagonal is 2052. So let me see, is 2052 of the options? It is in one of the options, that is option B. So sum of the numbers on the face diagonal of the cube face having numbers 8 and 505 on it can be option B, that is 2052. So in this way, I just had to fill one face. I figured out which face is one having 8 and 505, and for that face I filled one diagonal and I could answer the given question. So the answer is option B. Now let's go on to the next question. So this is a theta type question. The number of cubes which are painted only in blue is what? So in this case, I don't need to consider the numbers that are there on the individual this. I just need to find out how many cubes will be painted only in blue. So now if you consider the cubes faces 1 second, so you will see that this is your 8 into 8 into 8 cube. The cube face over at the bottom is blue. The one on the side is blue and the one on this side is blue. So how many cubes will be painted only in blue? The ones which are there. So if you consider any cube face, okay, you can split this up into, just consider any normal cube face. So you can split this up into, every cube you can split it up into 4 parts. Cubes that are completely inside the cube. If you have a cube that is unit cube that is completely inside the cube, that cube is not going to be painted at all. The second type is those that are on the face but not on the edges. The elements that are on the face will be painted with only one color because they are on the face of this. Then there are those elements that are on the edges of the cube. So the cubes that are on the edges will be painted on 2 faces. And the third type is those that are in the corners. The cubes that are in the corners will be painted with on 3 faces. Now if we consider, we have to consider how many are painted only in blue. Now for all of these 3 faces, the face cubes which are there in the middle as such, like here, these are the ones that are in the middle which have essentially, these are not at the corners nor on the edges. For these kind of cubes, they'll definitely for the blue faces have only blue paint. So first let's count how many face cubes are there. So we have an 8 into 8 face. So if I draw this out, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this is the 8 into 8 cube. So if I consider this, the cubes over here from this part to this part. So like over here in the middle from, I'll make this thicker. So this 6 into 6 square, these 36 cubes as such will have only the blue face as far as these 3 faces are concerned. So these 36 cubes on this face and on this face will have only blue color. So how many such face cubes are there which have only one color? Such face cubes, there are 3 faces and each face has 6 into 6 cubes which are only of one color. So the total number of face cubes which are lying on the face but not on the edges which have blue color is 6 into 6 into 3. So this is equal to 108 cubes. Now consider this edge, okay, and this edge. Now generally whenever you have edges, the edges are painted on 2 faces. The cubes on the edges are painted on 2 faces. The cubes on the corners are painted on 3 faces. Now consider these 2 edges. Here the 2 edges are between 2 blue faces. So both the painted faces are going to be blue faces. Over here also both these faces are going to be blue faces. So even we have to consider these cubes that are lying on the edge. If you consider the other edges, for example the edges over here and over here, this face is red. So this face is between blue and red. So the cubes lying on this edge will have one face painted blue and one face painted red. So we can't consider those cubes. Similarly for all other edges, other than the edges that are over here, at least one of the faces would be a red face. So we can't consider those edges. Even the corners, consider the 8 corners for example. The 8 corners over here, for example, this one is say 1. The unit cube having 1 on it. The unit cube having 1 on it is painted blue at the bottom. It is painted red in the front and it is painted blue on the side. So it also has some red paint in it and hence we can't count it. So all corners will have at least one face which is painted red. So because they have at least one face that is painted red, we cannot consider any of the corners. So essentially we have to consider these face cubes plus the cubes that lie on the two edges over there. So how many cubes lie on the edges and not the corners in this edge and on this edge? So on the edge you have 8 cubes. If you remove the 2 corner cubes, you have 6 cubes. So you have 6 cubes per edge, and there are 2 such edges. So the total number of cubes are 2 into 6, that is 12. So the total number of cubes that have only blue paint is 108 plus 12, that is 120. So the right answer to this question is 120. So if you can visualize, this is blue color, this is blue color. So everything lying along this edge over here at the bottom right side will have 6 cubes which have 2 faces painted with blue color. Similarly, on the left and bottom side you have an edge which has 6 cubes with 2 faces that are painted blue. Ignore the corners because all corners have at least one face with a red paint, and the ones which are actually lying at the bottom, the 6 into 6 kind of cubes at the bottom and the 6 into 6 cubes at the sides, these will also have only one paint, that is blue paint. So if we count all of this, we get 120 cubes. Now let's go to the third question. The sum of the numbers on the cubes which are painted on 3 faces is what? So which cubes are painted on 3 faces? Like we just discussed, the cubes that are at the corners are painted on 3 faces. Because the ones in the middle are painted on 1 face, the ones on the edge are painted on 2 faces, the ones in the corners are painted on 3 faces, the ones inside the cube are not painted at all. So if I have to find out how many are painted on 3 faces, I have to essentially find out the numbers that are there on the corners of the cube. So 4 corners I already know, so consider this. So I know one corner is 1, 8, 64 and 57, so I know 4 corners already. So 4 corners I have at the bottom are, so if I consider this cube again, so what is this corner? This corner is 1. What is this corner? This corner is 8. What is this corner? This corner is 57 and the last is 64. So this corner is 57 and this corner is 64. Okay. Now I have to consider what is the top corner over here. Firstly, if I see that I already know these 2 corners because I've already calculated for this face, right? So I already know what these 2 top corners are. I need to only calculate this top corner and this top corner as such. So what are these 2 top corners? These 2 top corners would be, I have calculated all the numbers on this face. So these 2 top corners are, no, this one top corner is 505. I have not calculated this corner, but it is pretty simple as such. So this is plus 1, this is minus 15. So instead of doing all of that, each row I have to add 64. So this would be plus 64, plus 64, plus 64. This is basically 8 plus 7 times 64. So I'll write 505 directly, but this is 8 plus 7 times 64. So let me put this one. This is 505. This is 8 plus 7 times 64. And this is 1 plus 7 times 64. And that one is 64 plus 7 times 64, that is 512. That is essentially 8 times 64, that is 512. So I know 1, 2, 3, 4, 5, 6 cubes. I need to calculate this in this cube. So what is, firstly what is 7 times 64? So 7 times 64 is, this is 28, 2, 42, 44, 48. 448 plus 1 is 449. And what is this? This is 8 plus 7 times 64. 448 plus 8 is, 448 plus 8 is what? This is plus 8, so this is 456. Okay, so you have 456 over here. So what are the cube corner numbers? The corner numbers are 1, 8, 57, 64. Then you have 57, 64 plus 456 plus 505 plus 512 plus 449. So let me try to take the sum of this. This is 9, so this will be 66, 66 plus this, so 130 plus 130 plus, let me try to add these two together. So this is 11 461, so 961, and the sum of these two is again 11 and 6, and so this is 961 again. So this is essentially, yeah, so 961 times 2 plus 130, so this is 2, so this is 18, 1922 plus 130, so this is 52, 2052. So the sum on the corners, sum of the numbers on the cubes which are painted in the three corners is basically 2052, which is same as the question answer that we had gotten earlier. So this sum is also 2052. Now let's go to the last question. The number of cubes which have at least two sides painted is. Now to answer this question, you do not need to consider the individual numbering of each unit cube. You can just calculate it by using basic cube concepts. So the number of these which have at least two sides painted is, here there's no restriction that it has to be only blue paint. So as I had said earlier, the cubes that are inside have no sides painted. The cubes on the faces have one side painted. The cubes on the edges have two sides painted, and the cubes on the corners have three sides painted. So if I say at least two sides, it is the sum of exactly 2 and exactly 3. So how many cubes have exactly two sides painted? Exactly 2 would be the edges. There are 12 edges, and each edge has 6 cubes, which are if you ignore the corners. So exactly 2 sides would be 12 times 6, so this is 72, and exactly 3 would be the sides would be the 8 corners. So this is 8, okay, so 8 corners. So the total number of cubes which have at least 2 sides painted is 72 plus 8, so this is 80. So there are 80 cubes which have at least 2 sides painted. So the right answer to this question is option is 80. So as you can see, this question is has two very easy questions which you could have solved without investing a whole lot of time. The first question was a pretty difficult one to solve, and looking at that question, many students might have skipped this set. But if you actually went through all the sets, you could have easily attempted 2 questions and gotten those 6 marks right without putting in a lot of effort or time as such. So always make sure that whenever you see a difficult set like this, which seems to require a lot of effort and lot of drawing and calculation, make sure that you do not miss out on the easy questions that are part or hidden inside this set as such. So as you could see, there were 2 easy questions you should have definitely attempted in this particular set as such. So this is how you solve this set. It requires like all 2D space LR problems, it requires you to draw it out, and once you start drawing it out, you see the logic behind it, and then it becomes easy to solve these kind of questions. Now that you know, please go into the study room and please start practicing the LR sets. The more you practice, the better you'll get at it. Hi friends, welcome to Krako's video series. I am Saili Kale. Today we are going to look at how to solve a simple Einstein's puzzle LR set. This is one of those sets that if it comes in CAT, you should definitely attempt, because it would be one of the easier sets of the exam. So let's take a look at the set. 4 friends A, B, C, D live in 4 different cities among Delhi, Mumbai, Kolkata and Hyderabad, not in any particular order. They are in 4 different years, 1st, 2nd, 3rd and 4th, and prefer 4 different colors among yellow, blue, green, red in no particular order. Additionally, we know that A, B, C and D do not prefer colors yellow, green, blue and red respectively. A lives in Delhi and prefers the color blue. A, B, C do not live in Mumbai, Delhi, Hyderabad and Kolkata respectively. The people living in Mumbai, Delhi, Kolkata and Hyderabad do not study in the 2nd, 3rd, 1st and 4th year respectively. The people living in Mumbai, Delhi, Kolkata and Hyderabad do not prefer blue, green, red and yellow colors respectively. A, B, C and D do not study in 2nd, 1st, 3rd and 4th year respectively. C prefers the color yellow. the people who study in first, second, third and fourth year do not prefer the colors green, yellow, blue and red respectively. So a lot of information is given, but basically it boils down. We have 4 people, 4 cities, 4 years and 4 colors. So let us first draw the table for that. So this is A, 3 and actually I'll just clear this actually, one second. I'll draw A. So I have the person, I have the 3 and this column I leave for all the negative information that I have. So what is negative information? Basically if you get the information that this is not the case, then you put all the negative information over here. So I have A, B, C and D. Then I have this city, year and color, and this is all the neg information that I have. Okay, so I know that A, so let me start putting information that is there. I'll first put in information where I have absolute. So like C prefers the yellow color, so this is yellow, and every time I use up a clue I'll just delete it so that I know for sure that I've used up the clue. So then it is not there in my this. A lives in Delhi and prefers the color blue. Color blue. Okay, so I'll remove this also. Okay, we know that I'll put in all the negative information and delete the clues that I've put in. A, B, C and D do not prefer the yellow colors yellow, green, blue and red respectively. So this is not yellow, this guy is not green, this guy is not blue and this guy is not red. Now the only colors that are really remaining are green and red. This guy is not green, so this guy must be red. That means this guy should be green. Okay, so I've figured out the colors pretty simply and I've used up this clue. I can strike it out. A, B, C and D do not live in Mumbai, Delhi, Hyderabad and Kolkata respectively. So this guy is this is not Mumbai, not Delhi, not Hyderabad and not Kolkata. If you think of it, not Delhi can be put for all the remaining 3 because Delhi has already been placed. So this is not Hyderabad, not Delhi. This is not Kolkata, not Delhi. So I'll put this information in. So I put this information, I'll strike out 3. The people living in Mumbai, Delhi, Kolkata and Hyderabad do not study in second, third, first and fourth years respectively. Now I just know who is actually studying in Delhi. So who is actually living in Delhi, and that person is A. So I know that he is not in the third year. So I can put this information, not third year. Not used up the clue, so I will not erase it. The people living in Mumbai, Delhi, Kolkata and Hyderabad do not prefer blue, green, yellow and red colors respectively. But I've already placed the colors, but using the colors I can then put which city they won't be in. So somebody who is in Mumbai does not like the blue color. Somebody who is in Delhi does not like the green color. That I already know. Somebody who is in Kolkata does not like the red color. So this guy is not in Kolkata because the Kolkata guy does not like the red color. Okay. Somebody who is in Hyderabad does not like the yellow color. So this guy is not in Hyderabad. This I have already written. So it's not information. Somebody who is in Mumbai does not like the blue color. So this guy is not in Mumbai. But that is already known. So it's okay. The person who is in Mumbai does not like the blue color. So the guy with blue color will not be in Mumbai. The guy with green color will not be in Delhi, which is fine. The guy with red color will not be in Kolkata. So I have added one information by that. And the guy with yellow color will not be in Hyderabad. So this information is already there. So this doesn't really have anything more to give, but I'm not sure whether I've completely used up the clue. So I'll keep it for now. A, B, C and D do not study in second, first, third and fourth year respectively. So this is not second, not third, not first, not third and not fourth. Okay, so I have 2 numbers over here. If I get one more number, then I can put the name of the year in it. And so this is done. Okay, people who study in first, second, third and fourth years do not prefer the colors green, yellow, blue and red respectively. So the guy who prefers green will not be in the first year. So this guy is not in first year. The guy who prefers yellow will not be in the second year. So this guy is not in second year. The guy who prefers blue will not be in the third year. So this guy is not in third year. The guy who prefers red will not be in the fourth year. So this guy is not in the fourth year as such. Okay, so this is the information I have till now. If I look at it, I have put in this information also. So now let me see what information I am missing and what I can use to fill. So this guy is not in Delhi and Kolkata. This guy is not in Hyderabad and Delhi. And so he can be in either Mumbai or Kolkata. This guy, if you see this is 1 and 4, this is 1 and 4, this is 2 and 3, this is 2 and 3. So this means that this is either 1 or 4. Correspondingly, this would be 4 or 1. So this is not 2, not 3. So this is 4 or 1. This is 1 or 4. Similarly, this guy is not 1, not 4. So this is either 2 or 3. Correspondingly, sorry, if this is either 2 or 3, correspondingly, this would, one second. This is either 2 or 3, so correspondingly this would be 3 or 2. Now, I know that the person who is there in, the person who is do not prefer color green, first is this, second is yellow. So this information I can put in for now. Let me try to figure out whether I can determine more from this, okay. So the person living in Mumbai does not study in the second year. So this guy is Delhi or Kolkata, not Delhi, not Kolkata. So it is Hyde or Mumbai. Then this guy is again this guy is not Delhi, not Kolkata. So again this guy is Hyde or Mumbai. So the Hyde or Mumbai would be over here, which would mean that this of these two, one would be Hyde, one would be Mumbai. So this the other this which is Kolkata, since Kolkata is not over here, not over here, and not over here also, so this guy will have to be Kolkata. So this guy is Hyde or Mumbai, this guy is Hyde or Mumbai. But I know that the guy who is in Kolkata is not there in the first year. So this guy is definitely in the fourth year. That means the Delhi guy is in the first year. Okay, so that I know. The Mumbai guy does not study in second. So if this is 2, then this is Hyde, and if it is 3, then it is Mumbai. If it is 3, then it is Mumbai, and if it is 2, it is Hyde. So I think I have put in all the information. People living in Mumbai, Delhi, Kolkata do not study in second, third, first or fourth year. So I put that Mumbai guy doesn't live in second, Delhi is not third, Kolkata is not first, and Hyderabad is not fourth. So I put that information in. So this I can strike off. People living in Mumbai, Delhi, Kolkata and Hyderabad do not prefer blue-green. So Mumbai is blue, and the only one that I don't know is Mumbai and Hyderabad. So Mumbai is blue and Hyderabad is yellow. So both of them are not part of this uncertainty. So this is not going to help remove that. So we can strike it out. The people, last one is the people who study in first, second, third, fourth year. Do not prefer the colors. So first does not prefer green, which is fine. Second does not prefer yellow, which again is fine. Third does not prefer blue, which is again fine. Fourth does not prefer red, so that is also fine. So this also does not add to any information I have. So I have used up all the clues, and this is as far as I have gotten. So I can I think I can I'm done from this point onwards. So I have used up all the clues. So this is the max table that I can get. Now let me try to answer the questions based on this information. Okay, so let me go to the first question. For how many friends can we uniquely determine the cities? So we can determine the cities for 2 friends, that is A and C. For B and D we cannot determine the cities. So the right answer is 2 friends. Then we let's go to the second question. Who prefers blue in which, and the person who prefers blue is in which year? The person who prefers blue is A and he is in year 1. So the right answer is option A, the first year. Now the third question is, who among the following is from Kolkata? We know that C is from Kolkata, so the right answer is option B, C. And the fourth question is, which of the following pair is definitely correct? A, 4th year. No, A is in the 1st year, so this is wrong. D, Mumbai. D, Mumbai might be true but is not necessarily true. D, Green. D, Green is necessarily true, so this is true. B, Mumbai. B, Mumbai can be true but is not necessarily true. So definitely correct is only option C. So option C is the right answer. So as you could see, this is how we solved the set. Once we made this table, it became trivially easy to answer all the questions that were there in the set. This is a typical Einstein's puzzle. Once you start placing information, it becomes easier to understand where all information should go. So now that you have solved the set, please go and practice more LR sets from the study room. Thank you for tuning in.